Suppose you want to make both a chocolate cake and a strawberry cake. Would you start from scratch each time for each cake? Isn't it better to handle the common tasks together? Cream the butter and sugar, add the eggs, mix in the flour and baking powder, and then add the milk. Now you have the base ready for the cakes. This generalized cake base is like an abstract class. It's not too appealing on its own, but you can divide it into two parts and mix chocolate into one and strawberry into the other. This way you use the same effort to create two specialized cakes with less work and repetition. It reduces effort by moving common tasks to a shared process. Abstract classes in Java offer a powerful way to design flexible, reusable, and maintainable code. By consolidating common functionality, you can ensure a consistent interface through abstract methods. In short, abstract classes are fundamental tools in object-oriented programming that cut down on code repetition. Let's bring this concept into a more familiar context. Remember Tony and Psychic. Although Tony is happy with the cooking, cleaning, and shopping that Psychic handles, Tony still has to drive Psychic everywhere. What if Tony could use a second robot to be a driver pilot, almost like a personal chauffeur? To solve this, Tony purchases a second robot named What a Driver, but needs help to program it. Now you will help Tony write a Java program to code the functionality of both Psychic and What a Driver. Just like with the cake example, it's not efficient to code everything twice. You need to move the common code to a common area. To do this, first you must identify the common properties between Psychic and What a Driver. For example, both robots need to recharge, have a mode of operation, and provide a user interface. This raises two questions. Do you code the exact same functionality twice? And what if one robot doesn't implement a required feature, like the menu system? This would result in Tony being unable to interact with the robot then. In answer to question 1, you can avoid duplicating code by moving the common properties and functionalities to a parent class called Robot. This will be your foundation. As the robot class will contain all shared properties and methods, it will have no specific functionality of its own. Now, what does anyone do with a robot that just charges and has a mode of operation without performing any tasks? Nothing, right? The purpose of the robot class is just to hold the common properties and functionality. That's where abstract classes come in. An abstract class serves as a blueprint, holding common code and ensuring certain methods are implemented in the subclasses. By declaring robot as an abstract class, you prevent an object of it from being created directly. Therefore, it only serves as a foundation for Psychic and What a Driver, and allows them to work with less code. You can implement extra specific properties and functionalities in the subclasses. Let's break this down further. The concept of an abstract class brings to the forefront two things. First, the abstract class is a placeholder for all the common code, properties, and functionalities. And secondly, if it only declares a functionality or method, it ensures that the method is implemented in the child classes. For example, the menu system has to be implemented in both the classes, which are the subclasses of the robot class. So how does this translate to Java? Let's start by creating the parent class robot and move the common code to it. To ensure an object of the class cannot be created, even accidentally, put the keyword abstract before the keyword class. This keyword abstract prevents an object of this class from being created. The second part is to ensure the functionality for the menu and the action to be undertaken is always implemented in the child classes, although the implementation may differ. You can do this by declaring abstract methods in the class robot. Let's start by declaring the method for the setChoice as a public abstract setChoice, open parenthesis, close parenthesis, semicolon. Next, you can declare the takeAction method as public abstract, takeAction, open parenthesis, close parenthesis, semicolon. Remember that an abstract method does not have the curly braces or body. If a method has no body, it must use the keyword abstract. This applies to the class as well. It is important to remember that a class may become abstract without any abstract methods inside it. Next, you can inherit Sidekick and WhatADriver from this abstract class robot. When you inherit from an abstract class, then you need to implement the abstract methods of the abstract methods, if such abstract methods exist. If you do not implement the methods, then the subclass would itself become abstract, and no objects of it can be created. Implementing the methods means giving the curly braces to the method. Java does not care whether there is code inside it or not. However, you have to include code if you want to perform an action. In this video, you learned how to use abstract classes to reuse code and force a subclass to implement a functionality by using abstract methods. Remember that the abstract class is the foundation that is used in all the subclasses, but never directly. In essence, abstract classes is not only a powerful way to design flexible, reusable, and maintainable code, but also a fundamental tool in object-oriented programming. By implementing abstract classes, you'll become an expert at reusing existing code.